This topic here is quintessential algebra. It's a very fundamental skill that we all need to have. We're going to talk about factoring quadratics in this topic. Now, much like a lot of topics in mathematics, it's one of those easy or hard things. There's really nothing to calculate, nothing to figure out. It's one of those you either know it or you don't know it. So much like those topics, I can't really give you an algorithm to help you do this every single time, but I do have some suggestions for you to consider and things to think about to help make factoring easier. So let's just talk about what the heck factoring quadratics is. Factoring quadratics is to take a quadratic trinomial, say something x squared plus something x plus c. This is an example of quadratic trinomial, three-term polynomial, and breaking it apart into the product of two linear factors, x plus or minus a number times x plus or minus another number, right? So basically changing sum of terms into product of factors. Now, again, you just have to know the structure. You just have to know the pattern. In a quadratic trinomial, if he's factorable into the product of two linear factors, the idea is that whatever you multiply these two terms, that should give you the first term in the trinomial. And when you multiply these last two terms, it should give you the last term of the trinomial. And then you just have to sort of guess and check via repeated distribution to make sure that the middle term is in sync. We're going to start off with the easy case here. We're going to start off with the leading coefficient equaling 1. We're going to start off with this a not being there, with this a being 1. Because when the leading coefficient is 1, it makes our thought process a little bit easier, because the yellow boxes will always just be a variable. So what are some things that I think about? What are some things I do when it comes to factoring quadratic trinomials? Say, for example, I ask you to factor x squared minus 2x minus 80. Well, the first thing I can do is always draw two sets of parentheses, because if I know he's factorable, it'll be the product of two linear factors. Since the leading coefficient is 1, there's no visible number from the x squared. I immediately just drop these x's, because that's the only simple way I can get an x squared, x times x. Now what I do is I take a look at this last number here. I ignore the positive and negative. Take the last number here and do what I call pairwise factor. So I'm going to find every pair of numbers that multiply to 80, and I do this systematically. I always start with 1 and the number. Now from 1, just increase, move to 2, then move to 3, then move to 4. And what I'm doing is I'm taking those numbers and dividing it into 80. If it goes in nice and neatly, I write down the answer. If not, I skip it. So for example, move on to 2. I will either do in my brain or on the calculator, I'll go to 80 divided by 2. Hey, it gives me a whole number, so I'll write it down. 2 and 40. Move on to 3. 80 divided by 3 will give you a decimal, so move on. 80 divided by 4 gives you a whole number, 20. 80 divided by 5, hey, that works. That's 16. 80 divided by 6 doesn't work. 80 divided by 7 doesn't work. 80 divided by 8, that does work. 80 divided by 9 doesn't work. Next, I would test 80 divided by 10. But since I've already written down a 10 here, that means I can stop. You know you can stop pairwise factoring when you've gone full circle. Next, you're going to look at the very last symbol here. This tells you add or subtract. And I hope, it's very obvious, if you see a minus, you think of subtract. If you see a plus, you think of add. So obviously, I'm going to think of subtract. What I have to do is look at these pairs here together. 1 and 80, 2 and 40, 4 and 20, so on and so forth. And I ask myself, which pair subtracts to the middle number? Again, ignore positive or negative. Just do big number minus small number for now. What pair subtracts to a 2? And I hope everyone can see that 10 minus 8 is 2. So that will be the numbers I put into here. But in these spaces here, I need to either put pluses and or minuses. How do I figure that out? That's where this symbol comes into play. You have this 8 here. You have this 10 here. You need to put pluses or minuses here to make this statement true. 8 and 10 is -2. Now you can either use mental math, or heck, if you're bad at mental math, just guess. Put something down, use a calculator, and check if it's right or wrong. If it's wrong, try again. I mean, you only have 4 options, right? It could be plus plus, it could be plus minus, it could be minus minus, or it could be minus plus. I mean, heck, again, if you don't know what to do, just guess something and see which one works. It's not a lot of guessing. Well, hopefully you'll end up knowing that it's +8 minus 10 gives you -2. So boom, there we go. That is the factor form of our original quadratic. So that's basically it. It's not a solving thing. There's nothing to calculate. Unfortunately, it's not something you can pop into a formula and get it. But I do offer some suggestions. Number 1, pairwise factor the last number. Number 2, the last symbol here will tell you of add or subtract. Find the pair from your list that adds or subtract to the middle number. Write down those numbers, setting equal to the middle number, and then just play with the positives and negatives until you get it correct. Let's do another example here. Suppose I ask you to factor x squares plus 13x plus 40. So let's start. Leading coefficient is 1, so I'll just do 2 sets of parentheses, x and x. The last number is 40, so I'll pairwise factor 40. 1 and 40. Divide by 2, that works. 2 and 20. Divide by 3, doesn't work. Divide by 4, that works. 4 and 10. Divide by 5, that works. 5 and 8. Divide by 6 doesn't work. Divide by 7 doesn't work. And then we're back to 8 here, so I can stop. This last symbol here tells me to think of add. Which pair adds to the middle number of 13? So hopefully everyone can see that 8 and 5 is my pair. So 5 and 8. So I'll write down 5, I'll write down 8, and it needs to equal the middle number of plus 13. So I'm going to put pluses and minuses on here until it's a true statement. Hopefully it's not a long process for you, but both positive needs to equal positive 13. So positive 5, positive 8, that is the factored form. It just takes practice. It takes practice until you can get really, really super duper fast at these. But I promise if you keep practicing, you should be able to get these down in 10 seconds flat. Now, it doesn't matter if I give you one variable or multiple variables. If the leading coefficient is 1, you start with the same thought process. We just have to tweak our original parentheses. So let's say we have factor x squares minus 12xy plus 35y squared. I know that looks scary, but notice the pattern here. You start with an x squared. Just focus on the x's. I'm going to highlight the x's. Here's the x, here's the x, and the last guy doesn't have any x's. So you start with x squares. In the middle is a single x, and you end with no x's. So although it's not a true quadratic, conceptually, this expression behaves similarly like our two previous expressions. Start with x squared, middle is a regular x, and you end with no x's. So if I'm asking to factor something like this, we can use the same techniques as before. So leading coefficient is 1, so I'm going to do 2 parentheses, x and x. The only difference here is since I have a y squared here, I'm also going to drop a y. That is the only difference. Everything else you treat the same. So let's go ahead and look at the last number, 35. Pairwise factor 35, that's 1 and 35. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7 does. And then that's it. Last symbol makes you think of add, which pair adds the middle number of 12. And hopefully you guys can see it's 5 and 7. It's not always going to be the last pair, guys. The examples I'm picking are just very coincidental. It could sometimes be in the middle. So I'm going to write down 5, 7 equals, and then the middle number is a negative 12. So I want a negative 12. So play with the pluses and minuses until you make this a true statement. Hopefully you end up getting negative 5 with a negative 7. So I'm going to put a 5 here and a 7 here. That's the only difference. Whatever numbers you end up with, just put it in front of the second variable. And then, of course, they're both negative. So this is the factored form of the original problem. So it may seem scary when you have multiple variables, but if you recognize it's the same quadratic pattern, it factors using the same logic. Let's just do one last example of these multivariable ones, and then hopefully you guys get the idea. So let's go ahead and factor, what would be a good one here? Let's try this one. Factor x squared minus 15xy plus 54y squared. First thing we should notice that we can actually factor it like a quadratic, because if you focus on just the x's, we have x, x, no x's, so it is the quadratic form. So two parentheses, x and x. We do have a y squared here, so we also need a y and a y. Last number is 54, so we have 54 here. Pairwise factor 1 and 54, 2 and 27, 3 and 18, 4 doesn't work, 5 doesn't work, 6 and 9. I think that's it. Oh my goodness, it's the last one again. Sorry guys, I really suck at picking examples. So the last symbol is a plus, so we think of add, and lo and behold, 6 and 9 adds to the middle number of 15. So I'll put the 6 here and put the 9 here. So 6, 9 equals the middle number of negative 15. Put pluses and minuses on these until it's true. Hopefully you guys can see it's a minus 6 and a minus 9. So once you get into the groove of things, factoring quadratics should be a simple task, and it's going to be an expectation that in the future, if I give you a quadratic, you should be able to factor it in about 10 to 15 seconds. Good luck.